Homework 14, section 7.2, applications of the standard normal distribution, video 8. In the previous video, I was wrapping up, and then I said, you know what, I'll make another video just to list the plans of attack in this section, and here they are. This all boils down to what you have versus what you want. That's life. What do you have? What do you want? And how do you get from what you have to what you want? In this case, if you have a mean, a standard deviation, and a measurement, an x value, and you want the area to the left of it under the curve, or the percent of the measurements that are less than x, or the probability that a value is less than x, then you calculate the z-score and find the area of left of z in the table. But if what you have is a mean, standard deviation, and measurement x, and you want to know the area to the right of it under the curve, or the percent of the measurements greater than x, or the probability that a measurement is greater than x, then you still calculate the x's z-score, but then you find the area to the right of the z, which is 1 minus the left area. Remember, your z table tells you left areas. If you have a mean, a standard deviation, and two x values, two measurements, then it's probably something to do with the in-between. The area between the two x's under the curve, the percent of the measurements between the two x's, or the probability that a measurement is between the two x's. Then you have to find the z-scores twice, once for each x. Then you look up both areas and subtract. You don't have to worry about left versus right. We've already had that discussion. But again, to find the area between, you look up both z-scores left areas and subtract the two. And then the last one we did is what I call a backwards z problem, where you're given a mean, a standard deviation, and either a left area or a right area. So you're starting with the percent already. And you want to know what's the measurement that cuts off that percent. Well, this one you have to work backwards. So you start with the area and use the table to find the z. Be careful if it's a right area because your table contains left areas. If you have a right area, 1 minus that will give you the left area. And then once you find that z, then just use the formula that converts the z back to an x. X equals mu plus z sigma. And in the last example, we actually saw an in-between problem backwards. You'll never be asked to do an in-between problem backwards unless it's perfectly centered at the unless it's perfectly centered about the mean. In other words, only if the two tails end up being the same areas. All right, if you have any questions, please contact me because this is kind of a lot to take in, but once you get into it, it actually flows pretty smoothly. Just draw a good picture, remember how the table works, and you're going to be okay.